Hi, this is Francesco Santini, and this is my lab report for Physics 2211 about motion of a free-falling object. The goal is to analyze the motion of an object falling, and then create a computational model which takes into account which forces act on an object in order to create a computational model able enough to predict the motion of a free-falling object. I analyzed the motion of a foam ball falling from my hand, and I obtained the following Y data, which were accurate enough because I calibrated them with the use of this calibration stick, which was calibrated according to my height, which is 6'1". And then I obtained this following frame data in order to obtain the time data. The law used for this type of motion of a free-falling object is Newton's second law of kinematics, which can be expanded into this following one. Since the object was at first still, but then when my object let the ball fall, the object started falling, it was possible to notice that the object was changing velocity. Therefore, the net force on the ball was non-zero. At first, I tried to evaluate whether the only force acting on the foam ball was just weight force, which weight force can be written as this following equation, which is the opposite of mass times the constant of gravitational acceleration times the unit vector of vertical motion. And then I create this following code, and then based upon a while loop, and then I made it run. As the following, and you can see that a parabola is formed, proving that the motion of the object was not a constant movement, as the force was acting on it, and obtain this following data of the motion, which shows that compared to the experimental data, which is this following, the computational data with only weight force was not enough. However, something was missing on the net force to be taken into account. In fact, when an object is dropped, it has to cope with the air resistance. And the resistance of the air is called force of drag. So I created a second model where both the weight force and the force of drag were taken into consideration. So I attempted to numerically determine the drag constant. However, this computational model and describing the motion of it failed in a pretty explicit way, from what it can be seen from this following that motion code running. In fact, from what it can be seen is that the motion, the object for some reason, is moving upwards when it should move downwards, because it was missing the fact that the weight force acting, if the weight force was only acting on the object, it would only be able to predict a position which was like larger than the original. In fact, after this resistance should prevent the object from moving and not make it move faster to the position to be predicted. One possible reason why the object failed to predict was most likely due to the optical effects from perspective, as it can be seen from this image. And then, as the object was in perspective, also the object did not fall in line, and when the object fell afterwards, as you can see, afterwards it started to bounce once and twice. Now let us evaluate the what-if scenario. If the object was initially thrown downward, the terminating velocity would have to be larger, because the drag force, which depends on the velocity of the object, would counter not only weight, but also the drag force. The drag force would have to counter that other downward force.